Welcome everyone to this video on the cosmology of the stars, and we're going to include some astronomy definitions. This is just to kind of give you an introduction into some of the terms that we've been using in the Bohemian star class and other star classes that we'll be doing in the future. We're very excited to share this information with you because, you know, it's helpful if you understand the terms and why they're defined in the ways that they are, and that gives us a sense of really being able to tune into this in a way that allows us to use these terms, and then you know what we're talking about. So anything you want to add to that, Eric?
Oh, thank you, Kaylin. No, it's good to talk about this to help people some of the terminology that is important when looking up at the sky, the night sky in particular, and a little bit of helping you navigate the night sky too.
Yeah, absolutely. So we're gonna start with talking about magnitude. This is something that, you know, the stars that we've been talking about their magnitude, how bright they are. So basically the magnitude of a star or a planet is the standard that astronomers use to measure the apparent brightness or objects of stars, comets, planets, etc. Everything has a magnitude. So the lower the number, the brighter the object. So, and we'll look at this a little bit more deeply in a moment, but the brightest stars in the sky are usually categorized as 0 magnitude or first magnitude stars, or even minus, because Sirius, the brightest star in our sky, is a minus 1.4 magnitude. So Eric, you want to share a little bit more about this?
Yeah, so which is exactly what Kaylin was saying there, and you can see on this graphic, you know, the whole range of like what these objects, what they show up as. So like the sun on the one extreme end, that's minus 26.7, almost minus 27, and it gives you the full day. But the moon, we could see it's less than half of it, and the moon can cast shadows, but it's not quite as full. But a full moon can give you that appearance. And then like certain other phases of the moon, there'll be less. It'll be a magnitude less, like at below minus 10, maybe minus 9, minus 7, that kind of territory there. Venus at its brightest, it can be around, on average, like a minus 4.6, but sometimes it gets up to minus 4.9, so very close to minus 5. And then you see, you know, we already talked about Sirius, and the naked eye limit goes into the plus territory. So the pluses are the ones that are harder to see compared to the full moon, the sun, and the bright planets. So you get in the plus territory, and you get up to like about plus 6-ish for the ones with really good eyesight. Some people, you know, can only see up to like a plus 4.5 to plus 5. You know, all depends on you know, your location, the humidity level, the clarity of the horizon. All of that has plays a huge impact on what stars you can actually see out there. But on the extreme end, Pluto is at plus 15. Can sometimes be as bright as plus 13, but it could be as dim as, I think you were looking at that plus 16.
16 or 17, something like that. Yeah.
Right. So now like there are artificial objects that orbit the Earth, and the most famous one is the besides the Hubble, which you can see sometimes with the naked eye, is the International Space Station, and it can actually be not quite as bright as Venus, but it can be up to a minus 2.5 to minus 3 in certain conditions. I've seen it where it's been minus 1, minus 2 range, you know, at various times in my life, and it passes overhead pretty quickly. And there are ways to look at that, but those are just ways to like measure the magnitude and looking at this and going, oh, what's that? What's the magnitude of that? And any night sky program on your or night sky app, or online at certain websites like Earth and Sky and Sky Telescope, you can get the magnitudes there as well, and other resources there. So that's That's magnitude.
Yes, and so go out and check it out. See Venus and see how bright she is compared to, say, even Jupiter. Jupiter is pretty
Yeah.
bright when Venus isn't in the sky, but you put Venus next to Jupiter and it's like, wow, she outshines Jupiter like crazy.
She does.
And of course, if the sun's in the sky, nothing else is really visible, maybe the moon if it's far enough away. So,
Right, exactly.
so that's pretty remarkable, yeah. So we also wanted to just give you a sense of how to measure degrees in the sky. So something that not everybody necessarily knows is that there are 30 degrees in a sign, right? And so there if you, and also when you can see planets a certain number of degrees away from each other. Uh, and so what the degrees are doing when we're looking at it in the sky is we're looking at the apparent size of objects or distances in the sky as seen from our vantage point. So it might be that if you were someplace else, it would have a different view, but from where we are standing on the earth is from our vantage point. So if you think about the moon, it's like 1/2 degree in width, and one finger is 1 degree. But this is if you like put your arm out, straight out, all the way out, and then hold up a finger. And so you can see here that like holding up the pinky finger, that's like 1 degree. And then if you hold up 3 fingers, that's like 5 degrees. So if you saw a planet over here and a planet over here, or a star or something, they'd be 5 degrees apart. If you put your fist out and hold it as a fist, then from one side of the fist to the other is 10 degrees. And then if you take your forefinger and your pinky finger and you hold that up, that's 15 degrees. And if you hold up your thumb and your pinky, that's 25 degrees. And you can see here that they have the dipper, and we're going to look at that in just a moment. But before we do that, is there anything you want to add to that, Eric?
No, I think you covered it great.
All right, well then you can do this one.
All right, so this is an example of in the night sky when one of the most famous asterisms or constellations that we can see here, the Big Dipper, which is part of the Ursa Major or the Great Bear. And there's, of course, other constellational mythology around this particular asterism. But getting to know the degrees, this gives you like an easy indication, and most people around the world can see this, except for those maybe in the extreme southern hemisphere might have some challenges seeing this, but most other people would be able to see this. And this is a great diagram because you can see in the actual like pan of the dipper, if you will, the cup of the dipper, you see that's 10 degrees. And then you get to like mid point of the handle gets up to 15, and then the whole thing, of course, from the point of the handle to the point of pot, 25 degrees. And then just extending a little bit more, a little bit farther to Polaris, which is the current North Star that we live in the age and we're living in here in the 20th and 21st centuries. This is the current North Star, and that's about 28 degrees from the Doob, the star Doob, and being at the end of the pot of the Big Dipper. So that can, like, it's wider than your, slightly wider than your pinky and thumb and spread out and with your arm extended. Again, this is all with your arm extended, not like held up right to your face, but way out and into the sky there. And that gives you that indication. Again, it's not an exact science. These are estimates, and but it gives you, that's how ancient peoples were able to tell certain things and calculate things and so forth. So we have that apparatus without needing a computer to do it. That we have that ability here with our physical body and our of being able to measure the distance between stars and or planets and so forth.
Beautiful. And just want to say that, in the Bohemian star class, we looked at Polaris as one of the possible Bohemian stars.
Right.
And we looked at the end of the handle of the Dipper. Alkaid was one, was also a Bohemian star. So we got two of them represented here. in this diagram about how to check out how to see the distances. And what's really cool is when you see planets coming together or planets coming together with stars, you can get a sense of how far they are from each other by knowing this information. So pretty cool.
Yes.
Yeah. Okay, so now we're gonna, these are a little bit more technical kinds of descriptions. And but worth knowing about. You don't have to, we're not gonna test you or anything.
At least not right at this moment.
Not
Maybe
right,
in the future.
Maybe in the future. Anyway, but just to give you a sense of that, because when you read articles and different things about what's going on in the sky, sometimes some of these terms are used, and it can be helpful to know. So 1 AU, or astronomical unit, is the distance from the sun to the earth. And that distance is about 93 million miles. So if somebody's saying it's it's like, say it's 10 AUs, that would be like 930 million miles.
Mm-hmm.
Something like that. So you can kind of get a sense of it. So do you want to do the arc seconds and arc minutes?
Yeah, and that's that 93 million is a rough average. So the Earth actually can at times in its orbit we're coming up at the time of this recording, we're coming up to the closest point in the Earth's orbit around the sun, which is only about, I think it was 1.8% difference in the closest point to the farthest point. So we have a pretty circular orbit, but 93 million is the number that everybody tosses around because it is the main average of the Earth's distance to the sun. So what Caitlin is bringing up here with arc seconds. So in astrology, we have when a planet is in a sign, it's got a degree and it's got a minute designation, and there's 30 degrees in each sign. And so a planetary body will be somewhere in whatever sign it might be in. And if you divide the degree up, you have 60 minutes. You have 60 minutes. And so 60 minutes equals 1 degree. And then if you divide the minutes up, you have 60 arc seconds, or 60 arc minutes to 60 arc seconds. So you can use arc minutes, or you can just use seconds, or use minutes and arc. You can put the arc there. Arc is more of a technical term. You don't necessarily need to put it in there. It's more astronomically that listed there. So the moon. So this is a great example. The moon is a perfect example of this. It's not like you're having to look directly at the sun to figure out. It's roughly the same size. That's why we have those eclipses. The moon is roughly a half a degree in size meaning that as we stand here on Earth or sit down or looking up at the sky, we're seeing the moon. And if you hold out your finger and extend it, and the moon is going to be slightly less than the finger. And sometimes the moon might be a little bit closer to the Earth and a little bit farther, but that gives you that rough estimate there. And that's a half degree. So it's a half a degree across the sky that moon is giving you. And it might look really big and bright, but it's only about a half degree. That's about roughly the same as the sun too. So now, the disk of Mars. So sometimes when you're reading astronomy magazines or online, and or telescopes, and they're saying, oh yeah, this is so many arc seconds in diameter, or this is almost like a whole half a arc minute. Then this is what we're talking about here. It's like the apparent size based on our position of the Earth. Now, Mars is a planet, like even Venus does this. All the planets do this on some level, where if it gets closer to the Earth, it's going to appear slightly bigger and brighter in the night sky. And there's various resources available that shows the wide range. Like in this example here, the disk of Mars is, I guess this is average at 20 arc seconds across. We can also say that it's, well, actually, hang on a second. Oh yeah, yeah, 20 arc seconds, where the moon is 30 arc minutes. So you can see how vast difference. So 1/90th of the apparent width of the moon. So that is very, very different from, like, oh, you sometimes see that. I reminds me of those fake news, like fake
Yeah.
news stories where it says the Mars is going to be as big as the moon
Yes.
in the sky. Oh my God, that never happens. Maybe when the solar system was really young, okay, maybe 4 billion years ago or whatever, maybe there was a certain situation where that happened in the youth of the solar system. But no, it never gets that big, and it can get a lot closer when the planet is at opposition to the sun, because Earth and that particular planet is going to be kind of in line with each other, with planets orbiting outside of Earth's orbit. So that's most of the planets. And for Venus and Mercury, that's going to be where Venus or Mercury will have just passed in between the Earth and Sun on some level. And so that's when you get a much brighter version after either they in the morning sky or in the evening sky. It all depends on where they are in their cycles. But that's the formula there. So 60 arc seconds to 1 arc minute, and 60 arc minutes to 1 degree. And that's what you've got there. And then the moon is 30 arc minutes, so just half of 1 zodiacal degree.
Beautiful. I just want to say that Mars or any planet near the moon is going to look like a dot in comparison. And or star, any star near the moon is also kind of going to look like that. So so just so you can kind of keep that in mind. And even if it's just the crescent moon, but the crescent moon is going to be still on that arc bigger than whatever planet or star it's passing. And then Eric, do you want to talk about the great coincidence?
Oh, yeah. So this is this has to do with eclipses. Okay. Yeah. So the moon is 1/400th of the distance to the sun, and the moon is also 1/400th of the size of the sun. And so we get this great coincidence. And you've got it listed as angular diameter here, mean angular diameter, which is basically just a technical term of saying the same thing that I was saying. And it just so happens, and there's a lot of theories about why this is. Some are really outlandish, and other things are like, put some question marks on that. What's going on there? But it's the magic of the harmony and synchronicity of the world in which we live and of the universe in which we live in. And it is a form of high magic. And there are other, from what I understand, there are other planets in our solar system that that not only have moons, but they have other times where they can get certain, not quite exactly what we have here, but they can get into that range. And it could be pretty cool from what I imagine, it could be pretty cool to witness that if you happen to be living on another planet, right? But this is something to keep in mind as you're looking at the world here on this planet and looking at this other world that's orbiting world. And actually, some astronomers, they talk about the moon as if it was almost like a captured planet. And in its early history, the strongest theory that they have is that there was at least astronomically, that there was another planetary body or the early part of the solar system over 4 billion years ago collided with Earth and ended up forming the raw material that is the moon. So it was part of, they called it Theia as the planetary body. So there's some interesting mythology around that, and there's actually even ancient Mesopotamia has stories about this, and it's fascinating, their creation myth. So the moon plays a role there, and you can keep going deep into that space. But I love that, now the moon is actually every year about 1 to 2 inches it drifts away from the Earth on average, and eventually in another billion years, I can't remember how many, well, it could be several million years, though, that the eclipses are going to be less frequent as far as like totality. But we just happen to live in a perfect time period over these thousands of years where it's like perfectly matched up right now. Like, why are we living in this time where it's perfectly matched up? That's a question that we can all ponder.
And I, the great coincidence also reminds me of the improbability factor about having one sun and one moon that look like they're the same size from Earth, even though they're not,
Hmm.
because of the way they're placed, as you were mentioning, Eric. And so that we can have eclipses, and that the probability of this happening is like, I can't remember the exact number, but it's something like 17 trillion to 1, right? So it's like super improbable that this would happen this way, because a lot of the planets in our solar system even have way more than one moon, and they wouldn't necessarily line up with the sun in the ways that it does
Yeah,
for us.
not as perfectly. Some of them, from what I understand, they can get close, but not quite.
Right.
Not nowhere near what we've got. But yeah, it's there are. I don't feel that there's no. I don't believe in coincidences, but I think that there's always a meaning, something symbolic, even on a basic level there.
Right.
But I, of course, I tend to be a very deep thinker, so I go deeper into the philosophy and the metaphysics and
Right.
beyond that. So
Yeah, but there's just that wow factor of like,
oh
oh, we live on a planet that has one sun and one moon, and they can, well, the Earth actually moves between the sun and the moon in a solar eclipse, but the moon can move across the face of the sun. I'm sorry, I said that backwards. In a lunar eclipse, the Earth moves
yes,
between the sun and the moon, and in a solar eclipse, the moon moves between the sun and the Earth. So, and it causes totality, like Eric said, and that won't always be the case based on how things are moving. So it is mind blowing just to think about the perfection of the mystery of the universe that we live in.
yes. Um,
Yeah,
that's a part of what makes it so magical.
it is. It is. Yep. So one of the things we talked about, especially in the classes we've already done, and we'll continue to do, probably talk about this, is declination. And we could say the literal definition of declination is the angular distance measured in degrees of a celestial body north or south of the celestial equator. So if we imagine that the equator of the Earth expanded into space is the celestial equator, and you measure object, like north or south of the celestial equator, then you can get the declination. So if it's 20 degrees, if it's minus 20 degrees, it's south, and if it's plus 20 degrees, it's north of the celestial equator. I hope I said that right.
Yes, you got it.
Okay, good. So suddenly I'm like, I hope I didn't turn that around, because I tend to be dyslexic sometimes. Anyway, so this is something that if you want to know if a star if a star is along the celestial equator, along the place where we're measuring this from, then you look at the declination and you can see how far north or south it is from that point, and that can give you a sense of whether it's whether it's going to be close to the ecliptic or the celestial equator, or if it's going to be further away. So, anything more about that?
Well, yeah. So you can, if a star is relatively close to the ecliptic, you could get the occultations of the moon
Yes.
over that. Did you? Because I don't know if you said. I know you
No, I
you
didn't
wrote it
say
here.
that. No, I
Okay.
wrote it, but I didn't say it. So good.
Okay. Yeah. So and we're, of course, at this time of this recording, we don't have any star occultations taking place in 2022 coming up here. But there will be some in the future, in the years after that. There's actually going to be some occultations of planets in 2022. And so if you're listening to this recording, you want to maybe connect with us or Google search that or whatever you want to do. Because Guy Otwell, Sky and Telescope, Earth Sky, so if you subscribe to some of these things, they give you heads ups on when those things take place.
Yeah, maybe what we'll do in the future is a video on some of, like when the moon is at its furthest declination, north or
Mhm.
south, and what stars get occulted as a result of that. So there's some more,
Yes.
more we can talk about this, but at least it gives you a sense of what we're talking about when we talk about declination.
Yep.
So, so you want to talk about this?
Oh yeah, this is just a graphic that is representative of the entire night sky or most of it, and it tells you like the great wheels in the sky. And you can see the North Star there in the center. We have two long wheels. One is the galactic equator, which is the not the celestial equator that we were just talking about in the last slide, but this is the actual Milky Way galaxy that we're seeing edge on from Earth, from our solar system. So that's the green circle. And then the pink circle, that's the ecliptic. That's where the plane of the solar system, where the sun crosses across the sky and the planets follow that track. So the Earth is tilted at a 23.5-degree angle, and that's why it's like offset from not only the equator, which is another circle kind of in the background there, but it shows you here what we call the two crosses, which are going to come up here, the solstice points that we're going to put some attention on. Now, again, we're just going over this briefly. There's going to be there's other resources that we're going to be making available in the future for more webinar series, so stay tuned for that. But it shows here on this slide the December solstice point and the June solstice point.
So now we're going to see it from a little different angle.
Mm-hmm.
Right. So the circle that Eric was talking about was the ecliptic that you said it was pink, right?
It was pink in that, but it's green here.
Yeah, it's green here. And then the celestial equator is red here. And then this is the plane of the galaxy, or the
Galactic equator.
galactic equator. Yes, thank you. And where these two cross is where the December solstice sun happens to rise, at least from 1962 to 2034. If you use, that's a half a degree on either side of the exact point. If you use a whole degree on either side, it's from 1926 to 2070. Either way, we're really in it. We're in this major shift happening. And these are the constellations that are along the ecliptic. The maiden, sometimes also called Virgo, the scale, sometimes called Libra, but it's the 0 Capricorn point that's where of the season of the December solstice, where the sun is rising on this cross between the Archer and the Scorpion. It's not in the constellation associated with Capricornus or the Sea Goat or whatever. It's way over here. So over time, the seasonal signs move through the constellations, and the reason we get confused is because we name them the same names, hence why we're calling them a different name. And so pretty cool to have this sun on the cross. And at the December solstice, or any solstice, June solstice, doesn't matter, the sun stands still for 3 days. And in a way, we could say it's like 3 weeks, because it's really, really close to that cross for about a week and a half before and after the exact solstice point. So this is pretty remarkable time that we're living in addition to all the other things we've already talked about.
Mm-hmm.
And then this is the other cross. This is, again, the galactic plane, purple line here, the green line being the ecliptic, or the plane of the solar system, and where they cross at the opposite part of the sky. And so this is where the June solstice sun rises at 0 Cancer, and between the twins and the bull. And then also Orion is reaching up, and it's like the sun is sitting on Orion's hand at the time of the June solstice. And again, we could say that this is happening from 1926 to 2070, 144-year window. And then we're kind of in the midst of the more precise window that lasts until 2034. So pretty amazing, remarkable. Wow, the sky mysteries just make me feel like we're living in magical times, for sure.
Absolutely.
Yeah.
So this is, go ahead.
No, you go ahead.
So this is a representation, another perspective, the two solstice points that Kane was just talking about, side by side. And they're also looked at as, quote, the two crosses in the sky. So these are the sort of the, what Danny Jumara likes to call as the bones, a part of the bones of the night sky, meaning kind of the structure of it. So the June solstice point has also been referred to as the Silver Gate, and where, mythologically speaking, where souls come into our galaxy and to Earth. And then onto the right side of the screen, we have where the souls leave, and that is the December solstice point, being the Golden Gate. That's the galactic center. That's where the sun is at the solstice, and zero Capricorn, what Caitlin was just talking about. So it's a really, in mythology and cultures throughout the globe have looked upon this as a place where souls go. Not necessarily every single culture is like that, but many have. And so we can look at it as a golden gate, symbolic as just, hey, this is where it's going. That's where the supermassive black hole is, where the galaxy spins around. And we're just one of billions of stars inside this particular galaxy. And we could even say maybe billions of souls that are anchored here and or go into the black hole, which is a powerful place where physics breaks down. Like, they don't really know what goes on inside a black hole. It's so intense, with the gravity so intense, that you just, supposedly nothing can survive, but there's something is occurring there that we can't fully understand. And I just find that notion fascinating, that it's like, well, how are we ever going to discover that? Well, I think, I don't know, but I do feel like it's like part of the mystery that we're all living in. And we can look to that as like, hey, there's that great anchor point where souls go, the Golden Gate, and maybe be rebirthed elsewhere.
Yeah,
one never knows.
I think about it like it's like the black hole or the alchemical cauldron, where things are being like maybe broken down into their quantum particles, and then because they have measured a lot of energy coming out of the black hole, out of the galactic center, and it I imagine it as like a new energy that's coming out, that it's been somehow alchemicalized. So when we tune into the December solstice point, we're tuning into that part of the sky where there's the big cauldron of energy coming in. And of course, then where the June solstice point is this energy coming in from beyond our galaxy, helping to inform us. So it is high magic, as Eric was saying, and we're just we'll have a lot more to say about this down the road. Yeah,
absolutely.
Yep. So meanwhile, we just want to say, hey, here's the link to the most recent My Star Alchemy class, and then we're going to have new classes that we'll post on mystaralchemy.com. And so we'd love to have you join us if this is something you find worth your time and attention and energy, and we would love to share more of the magic with you.
Thank you all. Enjoy the rest of your day and 2022 and beyond. We hope you have a magical time.
Thank you. Bye, everyone.
Bye-bye.